I think of myself as a working scientist. I don't do any research and haven't done for several years, but my main output is to act as a conduit between research scientists and other people. We talk about, in science communication, we talk about publics, plural, in order to represent the different types of public. There isn't one public, and I will give a different talk to you as I would do to undergraduates at UCL or to school children. And my job, my main output for my work is communicating to many different groups of people at all the time. So I'll give a talk at a school on one day, I'll be on the radio the next day. I'm here in Singapore giving these lectures today and tomorrow, which you should come to because they're super fun. But also I do talks at academic lectures within my areas of expertise, which is developmental genetics and population genetics. So establishing your credentials is important, but that doesn't mean that you should do what I'm about to do, which is spend the whole time talking about yourself. We've already talked about this a lot, and again, this is the central message. Who is your audience? And there are various ways you can work that out. One of them is cheating, which is to ask them. Often you will know who the audience is because you'll be standing in front of them because you've been an invited speaker, or you're on the radio, or you're on a TV program, and you'll have an idea of who it is, who is the key demographic, the key public that you're talking to. Sometimes, though, there will be overlaps between who those publics are. So that again, you should think about modifying what you're talking to based on the range of publics that you're talking to. So I'm just going to go through several aspects of my weirdly varied career. So I think primarily of myself as a writer. So I write books. This is one of my books, which was translated into multiple languages. And the point behind this is that you can see that there is in book writing, just judging by the covers, and I realize there is a phrase that you shouldn't judge a book by its cover. That is a lie. You can judge books by their covers. But just this is indicative of the fact that different countries have different styles and different interpretations of what books look like. And so I have very little control over the cover design. It's done by experts in their field who are book publishers. And what this shows is that, well, this is the UK version of this is a book about using ancient DNA to understand our history. So it's a retelling of human history using modern techniques in genetics. And the design, which I thought was absolutely terrific, it has family tree elements to it. And it's a typographic design, which means it's dominated by the words mostly because the title is ludicrously long. This is the Spanish version. When they went for a completely different design, which is based on the London Tube map, and various versions of it, which you see around the world, which I don't need to go into. But it's just a very simple indication of how the fact that not all audiences are different, the content to all of these books is identical, but it gets changed to reflect international audiences. A significant portion of my work, which is on TV. Now, again, apologies for this. This is a lot of pictures of me here. But these are programs I've made for the BBC on a wide range of topics, of which I'm an expert in some of them. So this was a program I did about 10 years ago, which is the history of biology effectively. This was a program I did about the history of genomics and the future of genomics. A pet subject of mine on the relationship between anatomy and art. So that was a very different venture for me. And as a presenter within that, what was key in terms of how we wrote the script and the style of presenting that I adapted for this program was not as an expert as I can be in the history of biology and in genomics, but was as an enthusiast. And that means that you're actually speaking in a different way. It's much less professorial, it's much less authoritative, but much more passionate and much more inquisitive. And so there I was talking to art historians and people well outside of my area of expertise, but in order that I would help the audience share my passion for this subject, which is just slightly different from what I was doing in these other programs, which are about genetics, which is more telling the audience interesting stories. I'll come to the difference between showing and telling in just a minute. I include this picture here because this is one of my favorite moments in my career. This is a program I made about synthetic biology, and this is where I met this goat who was had been genetically modified in the beginning of this century to produce spider silk in its milk, which is a great story to tell. And even though this is some pretty old technology, this was actually first done in the year 2000. It has remained a topic that really interests people continuously for the last 20 years. And whenever I tell people this, they still are absolutely fascinated by it, even though it's quite old tech at the moment. The reason I show this picture is because we used this picture in a newspaper when we were doing promotion for the series. And this was the image that we used. But the newspaper, which was The Guardian in the UK, they captioned it like this. Which I felt was somewhat unnecessary. But there you go. So that's television. Now, television is a very reductive medium. It's very unlike writing in books or writing academic papers. It is a very distancing medium. So when you write, you put the words from your brain into your fingers and they come up on the screen in front of you. And then it goes through an editorial process where I like being edited. Many people don't like being edited. But it becomes a collaborative process after that. But ultimately, you have a lot of control over what is coming out of your brain. TV is very distancing in terms of that, in relation to that process, in the sense that you may write some of the words, or sometimes you're given a script which you can change to suit how you want to speak about it, but you can't even see the shot, right? So where the camera is, you're being directed. The director will have an idea of how he or she wants to edit that program, but you have control over what comes out of your mouth, but not what goes on screen. And after you film, it goes into the edit, and you don't see that program again for another 6 weeks or 6 months. And then the next time you see it is when you do record the voiceover for it, or even if it's broadcast. So it's a very different process over which you have much less control. And as a reductive medium as well, it's much more, it's reaches a much broader public, and therefore you have to think much harder about how reductive you can be in terms of taking complex ideas like synthetic biology or like the history of anatomy, and convey them in a way which is both visual and engaging to a broad public. So it's a very, very different process from writing, and far less enjoyable as well. So that's TV covered in a short nutshell. My main regular output is I do the weekly program on BBC Radio 4, the main science program, which is every Thursday at 4:30. But you don't get it. And that is a weekly magazine show. Now, I'm the host of that show, and I have multiple roles within that definition as being the host. One of which is to just present the latest science news as it's being published. But again, the difference between talking about a subject that I'm an expert on, such as genetics, and the other areas of science which are being covered, so we're a program that covers all aspects of science, is that I have to take an active role in switching what I'm doing if I'm talking about astrophysics, which is enormously popular, but I know nothing about, or whether I'm talking about the latest discoveries in paleoanthropology, which I do know things about. And again, in some ways, this is a bit of a cheat, but there really are only 4 questions in science journalism, which are: what have you done? Why is it important? And what are you going to do next? Now, within that, never ask if there is one thing you want to take home from this, don't ask those questions, but you have to ask all of those questions. The other one, and this is the hardest thing to ask and answer, is what we really want to know when you're listening, particularly on the radio, which is a very engaging and personal medium, is how did you feel? Right? When you made this discovery, how did it make you feel? Now, the problem is humans are really bad at answering the question, how did it make you feel? Because it's a very sort of intrusive and personal question. So if you can elicit the answer to the question, how did it make you feel, without asking the question, how did it make you feel, then you get good radio out of that. So thinking a lot about trying to engage the person you're interviewing in order to elicit emotional responses, because that's what people want to hear. there's another aspect of this part of the job, which I absolutely love being on the radio. It's much more engaging than television because you have much more direct control. It's a live program, so there is an element of spontaneity in it. And so this is a sort of side tip here, which is no matter how much you prepare, you have to be prepared for stuff that is that you haven't anticipated. My favorite example of this ever in an interview was for a few years ago. There was the publication of the first publication of the mammoth genome, so the genome of a woolly mammoth that had been fossilized, or not fossilized, but preserved in the Arctic tundra for 10,000 years. And a team had managed to get soft tissue out of it, and they had sequenced the genome of the mammoth, which is an amazing story in itself. Now, I had my notes and I read the paper, and I started the interview with the lead author. And one of the early questions was something like, so you're digging around in the snow and you come across this mammoth. And before I got to the end of that sentence, he said, no, I've never been to the Arctic tundra, which kind of threw me a little bit because I even read the methods section because I do that. And he said, no, I've never been to the Arctic tundra. And I said, well, where did you get the samples from? And he said, eBay. Right. And I looked at my notes and thought, right, well, that's not going to really help me at this point because that is a really interesting thing to say. And that wasn't in the paper at all. And of course, that then became the focus of the interview while still trying to maintain talk about the science that was in the paper itself. But all of a sudden, I had to completely change tack. I had a very good producer in my ear on an earpiece who was sitting in front of a computer. And before the end of the interview, she had gone on eBay and looked for mammoth tissue and actually found some and told me. And then I could say in the interview, well, we could get hold of some for $114. But it completely changed the nature of that interview. And even though we didn't talk about the science in as much depth as I had planned, it was a much better interview for that spontaneity. I just want to quickly, in reference to the climate change thing, I just want to show you, this is the type of correspondence that we get. So the point of showing this is not so that you can actually read it, but this is the email that we received before the program had broadcast, had the trail for it having mentioned something about climate change. Now, this was actually 2 pages out of 14. The density of this content and the copy and pasting of these particular images, when we sometimes do text analysis on the emails that we get, and this is copy and pasted from central resources. We don't quite know where those resources started, but this is indicative of the industry that is behind the types of emails that get sent to every news outlet when they cover topics like climate change. So there are people queued up and waiting to say, oh, Inside Science has got a climate change story today. There you go, have it. So it's not very subtle. We're not going to read it because it's unreadable, but it's interesting. It's indicative of the mindset and the organization behind people who are doing this type of thing. This is something that Dom mentioned at the beginning, which is a question I get asked a lot by scientists. There's a lot of words on this slide, but as I say, I'm not a working scientist anymore, but I'm very closely associated with academia and science, and in many ways I represent scientists in the media. And so often, scientists express reluctance to talk to the media for various reasons. So let's just talk about the reasons why it is good to talk to the media. They're up there, you can read them. So obviously, to share your research. One of the things I say in the UK a lot is that the vast majority of research is done by researchers who are paid for by taxpayers. And that is different around the world, but I think that there is that means that there is a moral duty that research is not kept under lock and key, but you do report to the people who ultimately pay you, which is the demos, which is the taxpayer. A second reason is to justify your research. Well, I very much supports the notion of blue skies research and the notion that we should do as much academic research as we can because it's interesting. But not everyone thinks that. Politicians don't necessarily think that when they're thinking on short-term cycles of parliaments. We don't have a parliament at the moment, do we? No. And a lot of members of the public are baffled by the notion that we spend billions of pounds and dollars a year researching nematode worms or fruit flies or looking for quarks or things like that. And so I think it's important that scientists have a voice in telling the public that this is why we do it. Yes, because it's interesting, but also because here's a dozen reasons why we research quarks and fruit flies. Not at the same time. To own the narrative on your research is another reason to do that, because this is your story, right? And if you leave it to someone else to tell this story, they may not get it right. They may not get the details right. Sometimes they may tell it better than you, and we can talk about that later. But that leads on to the second point, which is if you don't tell your story, then someone else might. And this is a phenomenon we know very well in the media, which is that we have public commentators who are often very, very good, and they're generalists and will happily turn up to any interview that they're asked to appear on, regardless of whether it's their subject at all. On Inside Science, we try very hard not to talk to pundits or commentators, but actually to give voice to the researchers themselves. And within that, hard to talk not to PIs, but to the PhD students or the younger researchers or the first authors on papers who have done the research themselves. Sometimes that gets us into trouble because sometimes, I don't know whether you know this, but some PIs have quite large egos. And sometimes they like to talk about the research that they haven't done. So this is something that we're keen to encourage, that you can own your own story. And the other one is that I don't need to tell you this, but obviously science is important. But the mission for people like me, at least in the UK for the last few years, because we think we're going through a bit of a boom in science communication, is that science is important. And that we are trying to normalize the conversation about science and culture so that it's no longer acceptable for people to say in public, oh, I don't understand maths, or science is terrifying, because it's not, and it's important. Here's a question which I want us to think about. I'm not going to give you an answer to this, but the fact that you're in this room means that you're probably predisposed to one side of this as an answer. But I think it's a complex and nuanced question. Should scientists be obliged to talk to the media? My feeling is that no, they shouldn't be obliged, but they should be encouraged if they are in any way willing to do it. There are many scientists I know who just won't because they just don't like doing it at all. But I think that structurally within funding bodies and within the way scientific programs are formulated, my feeling is that science communication should be built into that and not an added extra. Right? And so I know tons, and you will know tons, and in fact, many of you people will be here under your own volition, taking time out from the lab. And I don't know what it's like in Singapore, but should you be in the lab doing experiments right now instead of listening to me? Okay. So there you go. You stayed late yesterday. That is exactly the point. You shouldn't have to stay late in order to do this. I think this should be part of a scientist's working lives, if that is their choice. But we can talk about that. Seeing as I'm already over, I'm just going to skip that and skip that. Reasons not to talk to the media. So these I sort of touched on those in the reasons to talk to the media. Most scientists are incredibly humble and incredibly precise about their areas of expertise. And so often I will hear a young researcher, more often female than male, who will say, if I ask them about population genetics, they'll say, oh, well, I don't really do population genetics. I do demographic genetics. Right? I'm like, well, I didn't even know there was a difference between those two things. When in fact, the fact that you're sitting in this room, or the fact that you've done a degree in biology, or the fact you've done any genetics at all, means that you are in the top 1% of experts in the history of humanity on the totality of biology and probably the whole of science compared to 99% of people listening. Now, that doesn't mean that you should talk about astrophysics if you're a geneticist. And it doesn't mean that you should talk necessarily about subjects where you know someone else who does know about this. But men will do this much more often than women, and women will almost always say, hey, this is not my field, to which I have to say, you know much more than everyone else about that. Second point, I have no media experience. Well, get some, right? Just that's what we're doing here. Get some, make friends with journalists, talk to people, write, blog, do that. If you're interested in talking about science beyond the lab, beyond a journal club, then get experiences. That's just a sort of practical point. The media will distort and simplify my research. Yes, they will. That will happen. But this goes back to the point about if you don't do it, someone else will, which is the bottom point, but also controlling your own narrative, right? So engaging in a relationship with the media in such a way that you can try to control your own narrative, because the media want different things from you, and you don't necessarily know what it is that the story is within the research that you've actually done, which I know sounds a terribly arrogant thing to say, but sometimes I'll read a paper and realize that the actual story that I want to tell is paragraph 14, conclusion 4, which doesn't negate the rest of the research that you've done. But this is the bit that I think the audience might find interesting. So attempting to control your own narrative. I mean, this is the next slide. Understanding what it is that the media wants. And you only get that by talking to people within the media. And so establishing that there should be a healthy conflict between what a journalist wants and what you want to do. Nobody on the news is going to allow you to read out a seminar or do a lab meeting on the 6 o'clock news. They will have 3 or 4 minutes tops for you, if you choose to talk about the last 4 years of your life and the millions of pounds worth of research that you've been doing in an enormous team. That's what you've got, and that's how the media plays. So you have to learn to play the game and understand what it is that the media wants in order that you get the best out of it. And if you have positive experiences like that by attempting to control the narrative, your narrative, then you will go back. The number of scientists that I talk to say, I won't talk to the media anymore because they screwed up my research. Well, they probably did, but you can mitigate for that by understanding the process much better. And I won't go through the rest of the slides. There you go. There's my last conclusion. There was lots of more detailed conclusions before that, but this is a positive thing that we do, right? So there is interrogation and journalistic aspects to science communication and debunking and those types of things. But for the most part, we're in this room because we love science and we love talking about it. And we think that it's important and all of those things. So be positive about it, and just a simple physical tip is that people sound nicer when they're smiling, when they're talking. I can hear that on the radio. I can hear when people are smiling, and stand up straight because people look better when they stand up straight. Because one of the key things that everyone says in all storytelling or all communication seminars or instructions is show, don't tell, right? But as with all of these types of instructions, that works some of the time if you deploy it carefully, because there are plenty of incidences where you do need to tell, right? Especially when you're talking about complex subjects, and especially this comes up when the difference between being professorial and invitational, which are two terms that TV executives like to use when talking about how a presenting style is. So professorial is me telling you this is how it is, and invitational is we're going to find out what happened. Now, these are styles. So because, for example, I said that in reference to the difference between me talking about the history of genetics and me talking about the history of anatomy in art, for which I have no academic qualifications. But the truth of the matter is that the level of discourse in a TV program is so low that you can become the expert by reading Wikipedia for Rembrandt, right? Or Galen. And by the time you've read that and read one book, you will know more than the content of the program itself. But because my credentials, so when I started, establish your credentials, because I can easily establish my credentials in genetics, because I have qualifications and positions in that, and I've published in that. I can't establish. I don't need to persuade you, and I can be professorial, and hopefully people will listen. Whereas I don't have any qualifications in the history of anatomy and art, other than being enthusiastic. So in doing that, you're trying to persuade the audience that they are going to continue to watch for the next hour on a program that, well, why the hell is this guy, who is a geneticist, a scientist on the radio, why is he telling me about Vesalius and Galen? And the reason is because he's super enthusiastic about it, right? And because it's a passion project. And you have to say, I hate the word passion in almost all situations, but you have to say things like that. All TV programs, all documentaries out of the BBC start in the same way, which is you have some pre-title teasers, they're called, and you have some dramatic shots of stuff that's going to happen in the program, some walking shots of you looking at things ponderously. And then you have to say something dramatic followed by, my name's Adam Rutherford, and I am blah, 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 blah. And so that is the moment where you're convincing people that they need to stick with you. It particularly happens in TV because TV is a medium which people switch off from very quickly. Whereas radio, people tend to be more engaged in that they have it on in the background. Books, very different because they've chosen and you know, you tend to get much more engagement in books. Audio books, even more so. So it's all of those things sort of combining into knowing who your audience is, knowing what the medium is, having some understanding of how people engage with that medium, which is different in all different forms of media, and then casting yourself as the person. So here was another. This is a related issue that I was going to talk about, which is the two questions that all commissioning editors should be asking, which is when you pitch an idea, they should say, why now and why should I care? Now, the answer to why should I care includes, well, who am I, right? Because part of my job is to tell you why you should care about this. And sometimes why should I care is because I care about it. And it's interesting to watch people who are passionate about something talk about things that they're passionate about. There are other reasons why should I care if it's climate change or genetic engineering or a big social issue or just because you know science is important. That's another answer. But that part of why should I care is why is it you and not some younger, better looking person who's better at presenting on the TV? Because they do exist, I'm told.
Thank you. Hello.
Hi, my question is that the audience that you tend to attract for your programs are in the 30s, but how do you communicate science with the young people and how do you reach out to them? Because these are who we want to attract, right? And so what are some of the media that you will use and some of the outreach program that you can target these people?
Well, that is the question. And the simple answer is, I don't know. But this is what we're engaged in right now. The Royal Institution Christmas Lectures have been running for how many years now? 170 or something like that. And they are designed to engage children, school-age children. And we do that through the way the lectures are structured, the demonstrations, the engagement with the audience, sort of getting them to participate. And I don't think it's unreasonable to say they're pretty successful at that and have been for a long time. I personally am terrified of children. I have 3 of my own. I'm partially terrified of them. But I find it difficult when I get invited to talk to schools, which I do every week. I am really comfortable talking to anyone over the age of 16. And I find it much more difficult to talk to people who are younger than 16 because the ideas that I'm interested in require such a level of background or sophistication that I don't really know how to explain it to them. Now, that is my problem. It's also education's problem. I predominantly talk about genetics and evolution. Evolution doesn't enter the syllabus in the UK until you're 16 anyway, which seems absolutely nuts to me. But this talks to a bigger conversation about trying to understand what science is, which is a methodology rather than a bank of knowledge. And we teach in the UK science as a bank of knowledge. We teach this is how things are, this is how they were discovered, primarily. Dom's the education expert here, so perhaps you should comment on that. But after Darwin published The Origin of Species, Thomas Huxley said, "How stupid of me not to have thought of that." And many people who talk about evolution in the public today quote that and say that it's so self-evidently true that it took a genius like Darwin to enlighten us. I don't think that's true. I think it's counterintuitive, and I don't think it's self-evident. And it took Darwin 30 years of really meticulous research to come up with the theory of evolution. Science is hard, right? And it requires a bank of knowledge and an understanding of history. And so I'm not answering your question. I'm just saying I don't know. One thing we do, there's another TV program that I make with a mathematician in the UK called Hannah Fry, who's giving the Royal Institution Christmas lectures this year. And we've done 60 episodes of a program which is called The Curious Cases of Rutherford and Fry. And it was always intended to be more fun and less serious and much more storytelling focused. They're short programs as well. They're only 15 minutes each. And we take a question that has come in from the audience and we address it between the two of us with experiments or through interviews or through storytelling. And it's such fun. I love making that program. And we didn't design it to be for children, but what we found is that it found a younger audience. And most of the questions now come in from children as young as 8 who are often listening with their parents. So we often get emails from a parent and the question has come in from their son or daughter. And so we don't tailor the program to children, but we continue to make a program that children have found under their own volition. So science is the opposite of common sense, right? The whole point of science is to remove our intellectual and emotional baggage from trying to understand how reality actually is. So that's the principle. But I have opinions, you have opinions. You wouldn't be doing science if you didn't have opinions. We're not robots. And opinions are important. I think they're increasingly important in an age of, I just remember that I've got, that's what I skipped over, in fact, this. So a paper that was published earlier this year, Scientific Communication in a Post-Truth Society. One of the conclusions of this paper, which I don't fully agree with, but it was an interesting discussion point, was about how we as scientists and science communicators it was questioning the notion of us simply being information providers rather than advocates. Now, no one in the scientific community seriously thinks that anthropogenic climate change is not real and a serious threat to human life on Earth and biodiversity on Earth, right? That is a non-controversial thing to say within the scientific community. It is a hugely controversial thing to say in the public discourse, where, at least in the UK, there's a roughly 50-50 split between people who think that anthropogenic climate change is real and not. I think it's like something like that. Yeah. And if you're talking about something like creationism, it's much lower in the UK, but in the US, I think from memory, the last stats suggested that something like 43% of Americans are wedded to some view of life on Earth as a result of divine intervention, right? Whereas evolution within the scientific community is a non-controversial thing to say. So I don't know what my opinions on this as a topic are, but to a certain extent, if there is a battleground in areas like climate change or understanding race in relation to genetics, if we adopt the view that science is merely the data provider, then we have lost those battles before we set foot on the field, right? And I don't know where the boundary lines lie, because you should be doing research which is as politically neutral as you can make it, because that's what science is. However, if we simply say, well, this is my research, now you can go and discuss it, there are active communities like the emails I get about climate change and like the millions of comments and emails I get about race science, where there are groups of people whose work is to take scientific ideas that are published by population geneticists and my colleagues and actively distort them. And so I track this in the new book, and there's been studies done. I spend a lot of time on racist websites and neo-Nazi websites, and there is a very active community that scans population genetics papers, takes the figures out or takes conclusions out of them, and either relabels them or turns them into memes. And by the time a paper that was published, last year, which only 8 people in the world would read, including me and my colleagues, by lunchtime on the day of publication, it's become, some of the figures have been relabeled and turned into memes and have been distributed on Stormfront, which is a neo-Nazi website, and hundreds of other websites all over Facebook. And that idea, which was published by, this is the data, this is just neutral, there's some scientists doing some good scientific work, has been weaponized on the day of publication with hugely potential detrimental consequences in terms of understanding what was actually in the research. And again, I say, well, we're neutral, we're just doing the data, we shouldn't be advocates. I don't know whether that is true anymore, particularly when it comes to controversial subjects such as race, pseudoscience, climate change. I think we've got over it with creationism. I think that, evolutionary biologists now, that is a sort of, I think maybe the reason it's a bit of a non-conversation in the UK at least is because we've got past that barrier. Most evolutionary biologists are advocates for evolution because it's so self-evidently true, and you're faced with arguments which are so self-evidently ideological that it's actually an easy battle to have. It's relatively easy to just disregard. I think in other areas like climate change and like race pseudoscience, it is much more difficult and also more threatening. Because are you going to be the guy that sticks your head above the parapet and says something for which you're going to get emails from neo-Nazis, or you're going to get litigation from climate change, well-funded climate change denying organizations, which is what happens to me a lot. That's a bold move to do. But I think there is a big question that all of us must think about, which is, where does the line between advocacy and being a scientist, where is that gray area? Be yourself, right? So this is part of the reason we do the exercises at the beginning, which is to talk about your research. Because sometimes what happens in an interview is I'll sit down with someone opposite them. Before we start recording, we'll chat, especially if I know them, or if it's an area that I know, or that they've just done something really exciting. We'll have a conversation, and we'll press record, and then they shut up, right? Or then they go, the experiment was done like this, and you're like, dude, what happened? Just tell me talk to me like you were talking to me before we switched the radio on. Now, you can't deceive people, you can't trick them into recording them when they're relaxed. But learn, try to talk to the media like you talk to me, or like you talk to someone at a party. Because if you start telling someone at a party that this experiment was done like this, you're gonna go home alone. Sometimes the model is explain this like you would talk to your grandma, which is a weird sort of sexist thing because my grandma was a physicist. So, and my grandfather worked in a printing press, so it'd be much better to explain that to him. But there is a reason to think about that. So you're actually scrutinizing what you're saying. But the other thing in an interview is, in terms of be yourself, is these are conversations, and mostly they're not news type interrogations. I had an interesting experience yesterday, which was that we were in talking about the Royal Institution lectures that we're recording this afternoon and tomorrow. I went onto the news channel, thinking that I was going to have a nice conversation with the hosts and talking about some of the fun stuff that we're doing. But it turned out to be quite an intense interrogation of some of the principles of science communication. And they are sometimes like that. There will be occasions where someone is going to try and nail you. Jeremy Paxman, who is a famous broadcaster in the UK, news journalist, he famously said that when he begins an interview with a politician, his starting point is, why is this lying to me? Right? Now, for the most part, that is not going to happen in science communication. So you can approach an interview saying, you did something interesting and I want to talk to you about that. So if you engage with them in that conversation in that manner, if you're yourself, then you will elicit, well, how did this feel? But it takes trust and it takes familiarity. And I think one of the reasons I get being part of the community, I think, is important. So even though I'm not an active researcher, in many ways I am, so closely associated with academics, particularly within my field, that I know a lot of them and they know my work and have established trust over a long time. So that can only come with engaging with the media. Whereas I suppose if they don't know who you are and they don't know that you're an expert or that you've got academic credentials in that field or that you've done good work, then maybe some scientists might be standoffish on the grounds that they think that the media might distort your work. So I don't know. I mean, just be yourself, but don't be too much of yourself, because it is a performance.